that, we will continue. So let's say we have two variables over here with these values for x and y. And just straight off the bat, one thing we notice by looking at this is that they follow the formula y is equal to 2x, right? Fairly simple, as x is 1, y is 2, x is 2, y is 4, and so on. So they are very, very highly correlated. So let's go about calculating the Pearson and Spearman coefficients for this. So you don't need to take my word for it, but the mean of x is 5.5, the mean of y is 11. And this table gives us calculations for xi minus mu x, yi minus mu y, and then xi minus mu x multiplied by yi minus mu y, sorry. And then to fit them into the formula for the Spearman coefficient, the Pearson coefficient, and we need to calculate the covariance first. So in order to calculate the covariance, we're going to have to sum up this particular column and divide by 9, right? Because we had n minus 1 in the denominator. We had sigma xi minus mu x, yi minus mu y, divided by n minus 1. That's the covariance. So that's what we're going to do. To calculate the covariance, we sum up that column, divide by 9, and that gives us a value of 18.33. And then in order to calculate the correlation coefficient, what we're going to need is the standard deviations of x and y. And it turns out the standard deviation of x, if we were to calculate from the table, is 3.028. The standard deviation of y is 6.055. And if you were to divide 18.33, which is the value obtained here, divided by each of these two values, we're going to get 1. Which makes sense, right? Because if we were to look at this, we have x and we have y, and we have y is equal to 2x. So we basically have a set of points that is like this. They all lie on the same straight line. So like this. It's not a great line, but yeah, that shows us that the line is a perfect fit for all of the points that lie on it. So that is going to give us a Pearson coefficient of 1. What is the Spearman coefficient in this case? Well, it turns out since x and y vary with each other, since y is equal to 2x, the rank of x and the rank of y are also going to be the same. So in this case, we also see the Spearman correlation coefficient being equal to 1, because as the rank of x increases, the rank of y is also increasing. So let's take another example, which is similar to the previous one. Using the previous example, what happens when y is equal to 3x instead of being y is equal to 2x in the previous case? What differences can we see? What differences can we expect in covariance and in correlation? What do we think? It turns out, let's maybe just think about it a little bit. We have the covariance is equal to xi minus mu x, yi minus mu y, divided by n minus 1. N minus 1 is going to be exactly the same in this case, right? So the covariance is going to depend entirely on the values of xi and yi. In this case, the values of xi are going to be exactly the same. So it's going to basically come down to yi. And if we were to calculate the mean of y, we would see that the mean is equal to 16.5 in this case. And so let's think about what that means for the values of yi minus mu y compared to the previous case, right? So let's take just one example from the previous case. We have 2 and we have the mean being 11. So let me color that differently. So we have yi is equal to 2, mu y is equal to 11. And so yi minus mu y is equal to -9, right? And in this case, we have yi is equal to 3 and mu y is equal to 16.5. So yi minus mu y is equal to -13.5. So right off the bat, we see that there is a much larger spread in the values of yi minus mu y. And this spread is going to lead to an increased value of the numerator. It might not seem intuitive right now because you might be like, hey, okay, we have a higher spread at the lower end, but we will also have a higher spread at the higher end, right? When we're talking about 10 and 30, and they should cancel each other out, but no, they don't. And the reason they don't is because xi minus mu x is going to be negative at the lower end, and it's going to be positive at the higher end. And when you multiply two negative numbers, you get a positive number. So xi minus mu x is also changing value as we go through this data set. So no, there is not going to be any cancellation of any terms over there. So what happens as a result of that is we actually find out that our covariance value is going to be higher if we have y is equal to 3x compared to y is equal to 2x. This comes back to something we said right at the start in the covariance video about covariance not being a good indication of the strength of the relationship. And that should be pretty clear right now, because if we have y is equal to 2x and y is equal to 3x, we have a set of points that fit that line perfectly in each case, but we still see a higher covariance in one case compared to the other. So what that means is we're going to see an increase in covariance. What does that mean for our correlation coefficient? And it turns out that it's not just the mean that's increasing, right? And it's not just the spread, it's also the standard deviation. The standard deviation is increasing because the spread is increasing. And it turns out that if you were to go through this and do the math, you would find that the standard deviation of x and the standard deviation of y basically increase by enough to compensate for the increase in the covariance. So when you actually calculate the Pearson correlation coefficient, we would see that the standard deviations actually cancel out with the numerator, yielding a correlation coefficient equal to 1. This is Pearson, right? And what about Spearman? We would see that nothing changes when it comes to Spearman as well, because Spearman is all about ranks, right? And the rank does not change in this case because we've merely changed it from y is equal to 2x to y is equal to 3x. The rank is not changing. X and y still would follow the exact same ranks. The rank of x and y would follow the exact same pattern in both examples. So our correct answer over here is this one. Covariance increases, but the correlation remains the same. That's option B. Perfect. With that, we get to the end of this video, and I will see you for the next one.